All right, welcome back. Pre-Calc. We're talking now the second part of 1.4b, or section 1.4. This is 1.4b, average rate of change. Much shorter video, much shorter concept, and I think a little easier concept as well. So we are going to do just that. We're going to determine the average rate of change of a function. Let's see, where have we seen that before? Average rate of change. Well, we go back to algebra, right? So we've got the average rate of change here between any 2 points on the graph of f is the slope of the line through those 2 points. Okay, so again, looking at the picture here, you've got a slope of 2 points on the curve and a line that goes through those. That slope of that line would be your rate of change, right? That's basically what slope is. And just to recall from geometry, that we call that line a secant. Remember, 1.4a, we talked about tangents having 1 point on the line. The secant actually passes through it and touches it twice. The line through 2 points on a curve is called a secant line. So the slope of that is denoted with this little symbol there. M is slope of the secant line. Okay, and then the average rate of change is going to be very similar. It's basically the slope formula. Instead of y2 minus y1, over x2 minus x1, we're using f of x2 minus f of x1 over x2 minus x1. So basically, your subtraction of y's over your subtraction of x's. It's a nice little review of slope formula. Okay, so that's it right there, right? We've seen that before in this form. Okay, so as we continue on here, let's find the average rate of change in each function. Now, there are a couple different ways you can do it. So basically, the only difference here, instead of just having points, is you're going to evaluate the function for these points here, and then the interval is where these points go here, okay? So a couple different ways in which to go about it, all right? So this first question here, find the average rate of change on each function on the given interval. So if we do that, let's remember that what we're doing here is we're saying f of x2 minus f of x1 over x2 minus x1, okay? So really what we're getting at here is we're going to evaluate the 3 here. This is your x1 and x2, right? So we're going to evaluate the 3 and the 2. We're putting these into the variables and getting those functions. So we can kind of do it whatever way you like. We can kind of write it all out there as is, or you can kind of evaluate it as you go here and plug those in first. So let's do it both ways. We'll do one example of each. So the first way is we're just going to kind of write it, use this whole fraction, and we'll just say, okay, that is equal to, well, f of x2, so it would actually be f of 3, because that's kind of what we're doing here, right? Because it kind of gets confusing with the numbers, but basically f of 3 minus f of 2 over 3 minus 2, right? Because we're taking the second point here, subtracting the first point. So on top, on the numerator, you're evaluating those functions, and the denominator, you're just kind of subtracting that interval, okay? All right, so first time through, we're just going to kind of write out the whole thing. So if we take this function here and plug in the 3, it would be 3 cubed minus 2 cubed squared minus 3 times 3 plus 2. Then we're going to subtract, right? Because we're going to have to evaluate the second one. And so that would be minus 2 cubed minus 3 times 2. Oh, did I miss one? Oh, yeah, times, oops, sorry, hold up. Minus 2 times 2 squared minus 3 times 2 plus 2. And all of that would be over 3 minus 2. Okay, so we could evaluate that mess and say, and we'll kind of save you some of the work. This whole function here, I know the first part of this whole section here, I kind of did the work for you, would be, comes out to 2 right? Because you've got 27 minus 18 minus 9 plus 2. So you end up with 2. So all that mess came out to 2. And then over here, this piece here also did the math for you. If you evaluate it, you're going to get in an 8 here, right? And then a negative 8 here. So those are going to cancel. And then you're going to have negative 6 plus 2 is a negative 4. So you end up having a 2. And remember the minus sign right here. So we're 2 subtract a negative 4 all over 3 minus 2, which is 1. So after we choom that, basically we have 6 over 1, which is equal to 6. Okay? So that's one way to do it. I don't know if you like that way, put it all in under one numerator. So it's kind of your choice. I think I like the second way better. It's just a little bit cleaner. So we'll do that over here. So on this one, remember, we know that what it is. We know the function is going to be we know it's going to be f of x2 minus f of x1 over x2 minus x1. So again, basically what we're saying is we're going to take f of minus 3 and subtract f of minus 5 after we plug them into this function here. Okay, and then it's going to be negative 3 minus a negative 5 on the bottom. Okay, we know that. All right. So the other way you can go about it is to just kind of evaluate each function and then plug them into this, right? If we just evaluate f of 3 and f minus 5, maybe that keeps this a little bit cleaner. I don't know. It's your choice, but we'll do that for this one. So what I'm going to do here, change colors, and so let's just evaluate f of minus 3 first. Right? So I'm just going to block that off, f of minus 3. Okay, so that's going to be negative 3 to the 4th power minus 6 times negative 3 squared plus 4 times minus 3. Okay, and we know after doing the math, we earned it with 81 here, minus 54 here, and minus 12. So we're going to end up with a positive 15. Okay, and then if we do the same thing with f of negative 5. So now I'm going to take that negative 5 and go negative 5 to the 4th power minus 6 times negative 5 squared plus 4 times negative 5. And I'm going to end up with after doing all that math, you're going to get 6. You're going to have large numbers here. 625 here, minus 150, minus 20. So in that case, we end up with a comes out to negative 450, or sorry, it comes out to 455, not negative, positive 455. Okay, so we have those values. So now if we just kind of scroll down, again, I'm looking here, I've got f of minus 3 and f of minus 5. So basically it's going to end up being 15 minus 455. Basically taking my f of negative 3 value, subtracting my f of negative 5 value, so 15 minus 455. And then I have this part here, the negative 3 minus the negative 5. So doing the math there, we end up with negative 440 over positive 2. Careful with your negatives. And so you end up with a negative 220 for the average rate of change. So there you go. All right, one more type of problem here with the word application, because we can do a lot of word applications here with, say, distance and speed, and a lot of times there's a common one with the falling object, okay? So this one says, but it's the same formula. So in this case, we can go, the formula for distance traveled by falling objects on the moon is by this function here. Distance equals 2.7 times t squared, where t is the time in seconds. So our interval here on the first one is 1 to 2 seconds. So basically what we're doing, we're using that same formula, and we're going to say we're kind of going f of 2 minus f of 1, okay, over that interval, 2 minus 1. Okay, so again, I can do it all at once. I'm kind of going to do that for you here. If you plug in 2 into this function right here, you're going to get 10.8. And then f of 1 is going to be 2.7. And then we know that 2 minus 1 goes in the denominator. Okay, so what ends up happening here is we know 2 minus 1 is 1. 10.8 minus 2.7 comes out to 8.1. And we would call this feet per second, right? Make sure we have word problems that we're labeling it. Okay, that was taking it right into the functions and subtracting them there. But you could also evaluate them both. So let's kind of do that on this one here. We'll kind of do the second evaluation. So if we go f, we're going from 3 to 2. So we're kind of going f of 3 minus f of 2 over 3 minus 2. That's kind of what we're looking at. So if I just let's do it the way where we evaluate the functions first. If I plug in f of 3, it's 2.7 times 3 squared, which gives us 24.3. Okay, I can evaluate f of 2 the same way, which gives us 10.8, as we know from part A over here. Okay, so then I just kind of take these values and plug them up into this formula here, and then we're ready to go. So then I say 24.3 minus 10.8 over 3 minus 2, and that gives us 13.5 feet per second. So again, it doesn't matter which way you do it. If you do it all right here on one big numerator, I don't like that as much because sometimes you mess up with your positives, negatives, and the whole thing's up. I like kind of this way better. If you evaluate each piece first and then put it into the formula, into the slope formula, basically the slope formula, it doesn't really matter what you do. Your choice on that. But that's it, rate of change, and using kind of the slope formula with curves and your secants. And how about that? Just 12 minutes. Woo. All right, we'll see you tomorrow. Bring questions if you got them. See you next time.